Assalamu alaikum, grade 9s. So yesterday we did the basics of our pneumatic system and our hydraulic system. Right. Now we're gonna look at an example. Okay, so when you were in grade 7, you should have did this already. If not, if you didn't do it, I suggested that you did it if you had the apparatus at home. But if you didn't, it's okay. I'm gonna try and explain it now. Maybe when we go back to school, we can try it out again. Okay, so with our syringe system, you can either make a pneumatic system, and this is when our syringes are filled with air, or you can make a hydraulic system. This is where our syringes are filled with oil or water. Okay, either one works. Now we are going to be going into depth with of the hydraulic system. Okay, so in our syringe system, we could have used one syringe that was larger, one syringe that was narrow. We could have used syringes that were the same size. We did this already in grade 7. Okay, I'm just going to discuss this one here in the meantime. So if you look here, if you push this syringe in, it will transfer the water all the way from here through this pipe, and this will move up on its own. Okay, so this syringe here is the input of the master, because this is the one that you are moving. This is the main one. The output of slave's syringe is the one that moves in response to the master. That is why it is the slave syringe. Okay, right. You do work when you push the master cylinder. The slave cylinder does work when it moves on the other side. The amount of work that you put in must be the same as the amount of work that comes out. Right? So the amount of energy that you are putting in here is the same as energy is transferred in this entire system. Okay? Now we are going to look at how we can change the forces using the hydraulic system. So please look at page 78. You will see there's a plastic bag filled with water. Now just imagine you fill a plastic bag with water and you poke one side with your finger. If you put another finger on the other side of the bag, you'll feel that you feel pressure on that finger. No matter where you put it on the bag, you will feel pressure. Right, and this is a way to describe Pascal's principle. It is when pressure is applied to a flexible container, for example, the plastic bag with liquid, the same pressure is felt everywhere. This shows that the pressure is transmitted or transferred equally through the liquid in all directions. Okay? Now, one thing you must note is that force is different from pressure. Remember, we did forces. We said that forces are a push or pull that will cause an object to move. That's if forces are imbalanced. We did it this year. Then we have pressure. Pressure is the amount of force applied at right angles to the surface of an object per unit area. So I'm going to use this using a balloon, right? I'm sure you guys did this in natural science already. Here, because of the amount of gas molecules inside of this balloon, they are constantly moving. They are colliding with the edge of the balloon. The more collisions, the higher the pressure. Just think of a gas tank that you use for a gas stove. A lot of gas is squeezed into that small area. It is under a lot of pressure because of the amount of collisions that the molecules are making against the edges.